So, hello everyone, let us now discuss reschedule meetings for maximum free time 2. This question we are given with event time. That means we start with 0 and end with event time. Here it is 5, right? Now we are also given events which start with start time and end at an end time. Each of length n. That means we are given with start time array and end time array. That means we have n events. Now, if you see, this is one event. If you this is one event, and these events are non-overlapping. So, if an event occurs at this, no event occurs in this time space. Now, we need to reschedule these meetings so that we get a maximum free time. So, imagine you are having two meetings here. Now, what will you do? If I get this meeting and reschedule it here, and remember that in the first question we need to maximum uh, reschedule the meetings of number k. But here we can only reschedule one meeting. Here, if you see, if I reschedule this meeting, I get 2 as the maximum free time. Now, if I reschedule or make this uh, here, then I'll get a maximum free time of 2. But the first observation from this example I got is, if you see, here I got 1 and here I got 1. So if I reschedule this meeting in the time space of the previous meeting, even though I don't have a previous meeting, here the previous meeting starts hypothetically at 0. No, the next meeting starts at 3. So if I scroll or make this meeting at here, at the left or at the right, then I get the free time of the left one, the free time of the left one, and also the free time of the right one. So the free time of the left or right, if I add that, it will be free, or the time gap of I minus 1 plus I plus 1. So this is my first observation. I have another example. I'll go through that example. So I got another event with this example, the same example which is given in the description. Now, the thing is, the first observation I got, like I can reschedule this to the left or this to the right before starting the next meeting. Now, I have another choice here. I can reschedule this to this. So, the first observation goes like this: time gap of I minus 1, even though if there is no free time gap, it will be 0 here, and then it will be like at this index it will be 7 minus 1, it is 6, and then I'll get here 8, 9 minus 8, it is 1, and then here I'll get 0 as my free time. So if I reschedule this to the right, then I can get a free time. If you see, then I can get a free time of 7 minus 0. That means 7 is my maximum free time. If you see here, I can only replace this to here or to the left or right, even though both are same. I can get 2 as my output. Now, the thing is, it is not as simple as that. If you see, I can reschedule here or here or here, even though these two are same. If I reschedule here, I'll get a maximum free time of 7 minus 1, which is 6. Now, there is one point we need to consider. This event might be having a length of 2. So what will I do at that time? Now I can reschedule this meeting at the left or right. Then I'll get, if you remember, I said free gaps of I minus 1 plus free gaps of I plus 1, which is here 2, and which is here it is 2. Now, can I place it over this meeting? Here I have a gap of 1, but my event is having a time, or the schedule or the event is of 2. The length is of 2 hours, but I have only gap of 1. I can't fit it here. So I don't make my event rescheduling at the right gap. So how do I know that? That's why I'll maintain two things. The first thing, this is the only two things which I need to maintain: free times or free gaps, whatever the name might be. Free times will store the free times here. It is 0, and here it is 2, and here it is 2, here it is 1. Remember this. This is not the example which is given. I have increased the length of the second meeting. Now, free time. And I'll maintain a maximum right. What does this maximum right stores? This maximum right stores the free time after the index, the maximum free time after the index. If you see here, it is 0, and when I get here, the maximum free time after this index will be 1, and at this index it will be 2, and at this index it will be 2, and after this index also it is 2. But I have another choice. If I take this, there is no maximum free time after this index, but I have a maximum left at here, so I need to maintain the maximum left too. So I get a maximum left. I need to go through every event and reschedule it to the left or right. That means if I reschedule to the left or right, then I'll get, in the first observation, free gap of I minus 1 plus free gap of I plus 1. And if I reschedule it to the next gap, or the gap after the next event, or the gap before the previous event, then I'll get another condition. So I'll iterate for I is equal to 0 to n for events, and now the scheduled time, or the current time I got is the end of I minus start of I. This is current event time. Now I have another thing. You got this right, you got this left. You will get this event or the free gap if you get this event to the left or right. So my first condition, that means I'll need to return the maximum free. This is the thing I need to return. So my maximum free will be maximum free, and maximum free, and the free gap to the left and to the right. Here, the free gap I minus 1, I plus 1. I just copy this. The free gap of I minus 1 plus I plus 1. So if I add these two, I'll get the free gap if I reschedule the meeting. And now I have another thing like maximum free right, maximum free, maximum free right. So the maximum free right after the index, if it is greater than the current event time. So if it is greater than the current event time, then I got current time. Then I got another condition. Now, if you see, imagine you are rescheduling this. Imagine there is another free gap after this event. Then what is the free time I'll get? I'll get here till here it is 2, and I have a event here. Then I have this one. So the free time of I plus 1, the free time of I minus 1, and the current meeting size. At this time, the same thing, free time of I minus 1 plus free time of I plus 1 plus the current event time. Here, the current time will be added. This need to be considered if we have maximum free write at the index is greater than the current time. So the maximum of this and also the maximum free. This is how you solve this problem. After this condition, the maximum free will be is equal to, this is the condition. Then as I said, I have this maximum left. So after every event, I will store the left. The maximum left will be the maximum of, let me take and copy this again, maximum left, comma, the left gap, the gap to the left. So free gap to the left will be free gap of I minus 1. So this is how you solve this problem. After this, you will be ending here, and also you will be having uh, another condition where you got either this maximum free rate of I is greater than current time, or or maximum left is greater than, remember this point, and it is important to add in your code, maximum left is greater than the same condition, current time. Then you will be doing this. So in the condition, don't forget to add this, and I'll end my iteration here and return maximum free as the output. So this will be my output, and if you like this video, share it to your friends and subscribe to my channel. First try the code, and if you don't get the code, go to the link in the description, you get my subscription. Thank you.